There's no big deal into bringing a DOS machine onto a network. The only problem is the network stacks consume lots of memory. So much so that especially older versions like DOS 3.3 easily drop way below 500k of free memory. Luckily, there's some strategies to optimize your DOS memory management.
Obsolete computer technology is my passion. I'm the vintage collector, and these are my stories.
I teased you in my last episode about Windows for Workgroups how it included also the real mode DOS network stack. Needless to say, running the real mode network stack puts quite some pressure onto the conventional memory, so the memory area below 640k.
First of all, what's the basic problem? Why do we have these memory problems?
The problem is that DOS applications have only 640k of memory to work with, which is called conventional memory. Regardless of how much memory is installed in your system, they're only limited to work with that. And you have, usually people have too many things running within that conventional memory, device drivers, memory resident utilities that take up that space.
Let's look at the example of MS-DOS 6, which was intentionally not yet optimized for memory consumption and just runs a minimum set of device drivers. As no UMBs have been configured, everything was placed into the conventional memory and consumes an overall 54k, leaving just about 585k free. As soon as I'm starting the Microsoft Network client, many additional TSRs are loaded, adding another 59k just for the network stack, dropping the conventional memory down to 526k free. And it gets even worse when adding additional device drivers, like here the mouse driver. Now take PC-DOS 3.3 as another example. While it's missing the mem command, you must use checkdisk instead, which will give you the current amount of free memory, which is 537k, with the same device drivers loaded as previously on MS-DOS 6. When loading up the network stack, you'll end up with a meager 477 kilobytes free. And the more TSRs and drivers you add, the more your precious conventional memory fills up. Now, maybe I should explain a bit about those terms like conventional and upper memory. This goes all back to the original design of the IBM PC. With the original 8088 and 8086 CPUs providing for 20 memory address lines, the CPU could only address a maximum of 1 megabyte of memory. IBM then defined the first 640 kilobytes as being the conventional memory to be used by the operating system and applications. The memory above 640k was called upper memory area and was reserved for system use, specifically for memory mapped ROM access for devices like graphics cards or the hard disk controller. From today's perspective, these limits may look ridiculous, but in 1981 these were totally reasonable. The original IBM PC 5150 sported 60 to 64 kilobytes of RAM in its original default configuration, with the first mainboard revision actually not supporting more than 256k. By 1983, the IBM XT was sporting a default of 128k, which was still way below the 640k barrier. It doesn't go without saying that Bill Gates is often claimed to have uttered the phrase that 604k ought to be enough for anybody. But this quote is more like an urban legend than an established fact, and there's many reports online dismantling that myth. Yet, even so, it wouldn't have been his or Microsoft's fault, but rather IBM's. But was it really IBM's fault and not rather Intel's? Well, whom to blame for working with a technology that simply wasn't advanced enough yet by the time? The 8286 that would have allowed the use of up to 60 megabytes of RAM wasn't available until 1982, neither was the 386, which came only in 1985 and theoretically supported up to 4 gigabytes of RAM. And the so-called protector mode, which allows to address these big chunks of memory in one go, wasn't available before the 286. Hence, as there was no advanced enough CPU, there was also no operating system supporting protector mode at the time when the original IBM PC was in development. As Bill Gates stated himself, they all were aware that the architecture would be good for only some 4 to 5 years. So the development to overcome those limitations from the original architecture happened, and by the time when OS2 was released in 1987, it could have been all over if everybody just switched over. But the problem was, OS2 was too resource demanding, and some say in the initial release also too unstable, while the DOS-based ecosystem was widely established already. However, by 1987, the 604K memory barrier had clearly started to become a problem. The IBM PS2 systems launched in 1987, mostly coming with a 512 or 640K base configuration by default, and compact stocked at least 1 MB into their then current portable 386 machines. And although OS2 was available and promised to solve the memory problems by 1987, and even with Windows NT becoming available in 1993, also running in protector mode and overcoming memory limits, it would take another 15 years until the early 2000s for DOS-based systems, including Windows 9X, to largely disappear. So, if an obviously limited system like DOS survived that long, there surely must have been some good strategies to cope with the memory limits and effectively overcoming them. As early as 1988, Microsoft started to bundle HiMem.sys with Windows 286 and Windows 386 2.1 to make use of the extended memory above 1 MB. HiMem.sys would eventually as well be included with MS-DOS 5 to allow relocating the DOS kernel into the high memory area. In 1986, Compaq developed an expanded memory manager called QEMM. QEMM was bundled with Compaq MS-DOS 3.1 and later reworked into Microsoft's EMM386 expanded memory manager, which was then bundled with MS-DOS 4.0 in 1988 and with Windows 3.0 in 1990. With the advent of MS-DOS 5, it was furtherly enhanced to make unused memory segments in the upper memory area available for loading drivers and terminate and stay resident programs into these so-called upper memory blocks. So let's make use of these features here at the example of MS-DOS 6. First, I add the statement to config.sys for loading DOS into the high memory area and also providing UMB support so we can use the memory blocks provided by EMM386. Of course, I have to load EMM386. I instruct it to not provide expanded memory as I don't need that, I just need the upper memory blocks. Now rewrite all device statements except for HiMem.sys and EMM386.exe to read as device high to load those drivers into the UMBs. In autoexec.bat, identify the terminate and stay resident programs like Smart Drive and Mouse. Add a load high or LH statement in front to have them loaded into the UMBs as well. After another reboot, we'll see that with just these simple measures, we gain 139K of upper memory, of which 51K is now used. At the same time, the free conventional memory has already increased to an overall 614K. When now loading the network stack, it will automatically make use of the UMBs as much as possible. Only the basic redirector loads into the conventional memory, leaving me with an overall 603K free.
All right, let's go back to the 640K problem. You don't have to do anything complicated. If you have DOS 6 or better, you can actually run a utility called MemMaker to reallocate memory and solve some of those problems, right?
While we're still at MS-DOS 6, let's look at MemMaker. This was a utility included with MS-DOS 6, which was said to perform all these optimization work in an automated way for you. So I reverted to my previous non-optimized config files and ran MemMaker. Let's do it in custom mode so we get a bit more control. This is as important as I decidedly want to turn off EMS support. I don't want to deal with specific TSRs, but have it for certain consider Windows in the optimization run. If you're certain not to use monochrome graphics, you can also include that, but I'm skipping this as I didn't bother for it in my manual optimization as well. MemMaker will then reboot your machine and calculate your memory footprint. This may take several iterations until it has calculated the optimal configuration, for which you get also a brief summary. But let's look at the actual mem command instead. It provides 615K free conventional memory, 1K more than my own configuration. The reason was that it caught setvar, which I had forgotten to load into the UMBs. For the upper memory, it only provides 107K, but that's because I told MemMaker to apply memory reservation for running Windows. Still, it would relocate all TSRs into the UMBs, and when again loading the network stack, I'll end up at 603K free conventional memory, so the same as before. For the UMBs, they're pretty much used up now, but again, that's because of the memory reservation for Windows. Granted, MS-DOS 5 didn't include MemMaker, but all the other capabilities I just have shown were already there, and so was the case for the almost identical IBM PC DOS 5. In overall, this is already quite okay-ish to improve your DOS memory consumption. But as mentioned, the memory issues largely started to show already in the mid-80s. And older versions like IBM and MS-DOS 4 and 3.x neither supported relocating the DOS kernel into the high memory area, nor to make direct use of the UMBs for loading drivers and TSRs high. This is where third-party memory managers came into play. These existed long before Microsoft and IBM had extended their DOS versions to provide that functionality natively. Let's look at Qualitas 386 Max at the example of IBM DOS 3.3. It would ask a bunch of questions already during the installation procedure and eventually run the memory optimizer. This works largely the same as seen before with MemMaker, performing an analysis on how to load your drivers and TSRs the best way. And as you see here, I had added additional drivers for a CD-ROM drive to make the memory consumption already quite painful on DOS 3.3. After the optimization run, CheckDisk will now report an overall of 566K free, so roughly 30K more than in my original non-optimized run. Loading the network stack will end up at 543K free, which is a lot better as when compared to the original outcome at 477K. But how did it achieve this, since before DOS 5 there was no device high or load high commands? Looking at the configs.sys and autoexec.bat reveals that 386 Max is using special loaders to call out to our drivers and TSRs in order to make them load into the UMBs. But 386 Max was not the only such product. QEMM by Quarterdeck was widely used as well, and when running it with the same driver configuration, it fares much better than 386 Max, squeezing out a whopping 628K free conventional memory from this ancient DOS 3.3 with the same set of drivers. Now, I was curious to see QEMM on MS-DOS 6, and I was stunned to see a whopping total of 634K free base memory. Now, I never had used QEMM, so this was really a surprise to me. As you may notice, the drivers and TSRs have now disappeared from the mem command output. That's because QEMM uses some kind of cloaking technology. It even blends out the UMBs, so QEMM has the full control over them. To see what was actually loaded high, use the load high command. As you see, there's only 29K free in the UMBs, and when loading the network stack, most of it loads into the conventional memory as there's not enough room in the UMBs. Using the QEMM memory command, we get a report of how many UMBs were enabled, and this was only a meager 112K. That's because by default, QEMM provides for an EMS page frame. Now, if you don't have any applications demanding for expanded memory, disabling the page frame and EMS can help already. This is achieved through the qconfig program, where you set the page frame to none. I additionally added a manual config statement reading EMS:"n" to disable expanded memory entirely, as I don't run any applications requiring EMS at all. Don't forget to rerun Optimize, which will thereafter leave me with a lot more UMBs, 92K free after startup. Loading the network stack then pushed a lot less into the conventional memory, leaving me with an overall 612K free. Let's leave it at that, as I want to look into another product for comparison. But before, I want to look at yet another maybe not so obvious memory optimization method that has not so much to do with a memory manager. DOS comes with many drivers, and it's obvious you should ask yourself if you need all the bells and whistles like localized keyboards, country.sys, display.sys, ANSI.sys, DOS key and whatnot. Sure, some of them have their use and comfort, and one would not want to miss them, but they quickly start to accumulate, especially as we're only talking kilobytes here. As you saw, I pretty much left out everything except for the mouse and CD-ROM drivers. But boy, do they consume an overall 72K of memory already. So wouldn't it be nice to replace them by more memory conserving alternatives? Like here, replacing the Logitech mouse driver by QtMouse or MSCDX by the open source counterpart SHSU CDX. Even the IDE CD-ROM device driver itself, for which I use the one by LG, can be replaced by smaller but functionally equivalent alternatives, be it VID-CDD or small IDE. And here again, just with my manual optimization from the beginning, but the much smaller drivers and TSRs, the consumption on the UMBs is way smaller than before. Now pair that with those memory managers, like here, yet another product, Netroom by Helix Software.
What's that? It looks like MemMaker.
Exactly. Microsoft had actually licensed Netroom and incorporated some of its features directly into MS-DOS 6. But not all of them, as we're just about to see. Netroom replaces HiMem and the MM386 by its own memory manager, and just when looking at the conventional memory, it's maybe not as stunning as QEMM, leaving an overall of 615K free. So in this respect, it's on par to the MS-DOS 6 and MemMaker combo. But it certainly was more aggressive at finding free upper memory blocks, a whopping 252K total to load drivers high, of which still large chunks are free to use. Talking about MS-DOS 6, I need to briefly mention IBM's PC-DOS 6.1 as well. Instead of MemMaker, PC-DOS 6 included RamBoost, which was coming from Central Point Software. That's because up and until MS-DOS and PC-DOS 5, IBM and Microsoft were co-developing DOS still on a collaborative basis, whereas they split up afterwards. That's why we see bigger differences between MS-DOS and PC-DOS starting from release 6 onwards. Anyway, RamBoost is similar in technology to other products I have just shown and is simply run by invoking the RAM setup command. It will then also perform a series of reboots to analyze your system configuration. However, as it turned out for me, it was stuck in an endless reboot loop, obviously caused by the fact that RamBoost is not year 2000 safe. I had to specifically set a date before the year 2000 for it to work properly, as it obviously is checking the file dates and can't deal with files being updated any date newer than 2000. With that obstacle out of the way, I ended up with an overall of 618K conventional memory free and all drivers loaded into the UMBs. One of the biggest challenges in the DOS market was surely DR-DOS by Gary Kildall's digital research. Looking at the non-optimized DR-DOS 6, the memory footprint is catastrophic. However, DR-DOS 6, which came in 1991, included already a memory optimizer 2 years ahead of MS-DOS 6. Not as automated as other products, MemoryMax, as it was called, could be configured from the system's setup program and provided for similar optimization outcomes as we had just seen. But there's even more dimensions to memory management on DOS as you have seen today. Like the question of all questions, was DOS really limited to 640K base memory, and is there ways to have more conventional memory? No, I'm not talking about upper memory blocks, but extending the conventional memory space up to 704K or even 896K. For real? We'll see on my upcoming episode. I'm the Vintage Collector, and this was my story for today. Thanks for watching, and see you again next Sunday.